Hello. So I will talk with a bad accent, and I will talk about XSLT security. So for non-French people, if you don't understand what I say, just ask a French guy near you. There is plenty of. So I am Nicolas Gregoire, also known as Nicob, and I will quickly introduce myself. So I'm doing computer security for more than 10 years. I spend half of my time as a consultant and half as an end user, even if I was doing internal consulting. I have now my own company, which is doing only offensive security, mainly pen testing, web application or not, audit and some research. So this research was partly sponsored by one of my customers. So I wanted to thank him because he gave me some money, and we have a very nice initial brainstorming. So I'm very happy too to be in Disneyland with all my family. That's fun. So the plan. I will first give an overview of the research. What is it? What is the goal? Or do you try to resolve the problem? Then I will describe XSLT. What is XSLT? In which case do we use it? Then I will explain the methodology in details, how we are looking for vulnerabilities. We will find some risks that I will describe, and then we will map this risk to application, and then ideally we will find ton of vulnerabilities. A quick word about exploitation for this kind of primitives, and then we will conclude. So, easy. Modern software is really complex. You have a lot of third-party code, which is included in near any application. You always have some library like zlib, for example, or OpenSSL. And I think, in my opinion, that if you do not audit this code, it's not a trusted code, even if it's an Apache.org project. I do not see why I should trust Apache more than the average developer. So that's a typical modern Java application with a lot of libraries. So you have the library name and its family. So you have crypto stuff, Ajax, PDF, whatever. And we need to assess this kind of application. So we choose to take a bottom-up approach. So we will study the basic components, and then we will try to go up and map the functionalities to business logic and try to subvert the application. So in this kind of virtual application, we will choose one family of components. So we choose XSLT1. And for example, Xalange is a XSLT engine from Apache. Why this kind of components could be interesting for us as hackers? Because you have some very interesting functionalities. So that's a basic Xalange command execution. So you just map a namespace here, and then you call get runtime and your command, and you get command execution. If this is a feature, there is probably some cases where it's exploitable from the remotely, for example. So it could be a nice research. An important point is that we will try to exploit features of the XSLT engines, and so we do not have problem like memory corruption. And given this point, we will have very reliable exploit, which is always a good thing. Java exploit, for example. So what is XSLT? Who know already what is XSLT? Okay, so I need to do this part. The organizer asked me to be a little short. Okay. So XSLT. It's a W3C norm, which is at this URL. It is used to transform some XML document in another document, which could be XML or not. So you can produce a document like PDF, SVG, text, whatever. The important point is language, because it's really a real language. So it's a functional language, so most of us don't play usually with this kind of language. It's a bit surprising. But the important thing is that this language is Turing complete. There is some proof which are available online. And you can too have some nice tricks, like Queen. Queen is a program which will output itself. So it's somewhat funny to write this kind of stuff. And here one in XSLT. Every code I will show in this presentation is available online, so there is no my own code in this presentation, only to be compliant with French law, LCEN, and similar things. So, first example, we have a CD collection, which is described by a XML file. So you have a root entry, which is catalog. You have several CD entries which describe one CD. And we want to have this kind of result, so HTML page. The solution is to transform the XML document with XSLT. So it's really basic. Some stuff here. I then generate the header of the HTML page. I begin a table, and for each row, I will fetch the CD entry in the catalog, and I will extract title and artist, and insert in the result page. So you get this kind of output. Here, you have a command line working under libxslt, the XSLT engine from GNOME, where you have your catalog here, you have the style sheet here, this file, and you get your output. Very classic. Another example with a small tweak. Nmap, everybody knows Nmap. You have output in XML format. And you have two ways to render this data in HTML. The first one, you do an offline transformation from XML to HTML. Then you open the HTML file in your browser, and you can visualize the result. Okay, that's the same thing that the previous example. Second way to do the same thing, you directly open the XML file in a browser. And then you get on-the-fly transformation to HTML or XHTML, and then you can visualize the same content. The magic thing is that we get on-the-fly transformation, so we were able to trigger the XSLT engine inside the browser and get our code executed inside the browser. So that's an extract from the Nmap documentation. The important part is this one. We have this kind of tag, which is a processing instruction, and which will tell to the engine to start a transformation using this file as the transformation code. So that's the trigger which will allow us to execute some XSLT transformation in the browser. The interesting part is to remember that we need a way to trigger XSLT in a browser or another application. We just see one way to trigger this condition, and we have several other ways we will describe later. That's our basic methodology. We will first select some XSLT engine. Excuse me. We will then enumerate the features. So we have some tools to do that automatically. We will identify some dangerous features. I will describe how to restrict to dangerous one and how we define dangerous. We will write a proof of concept code for every dangerous feature in order to have easy reproducibility. We will need a way to trigger XSLT, so we need containers. So, for example, XML with processing instruction, or SVG, or more. And then we just need to run some application using our container, which include our proof of concept. And in most of the case, we gain vulnerabilities and then profit. So, engine selection, we have two families. We choose some very generalist engine from GNOME, Apache, Microsoft, and Saxonica, and some very specific one which are used mainly in one product. So Opera and Firefox on the browser side, and Altova, which is a tool designed to design XML. Okay, so that's the version and the URL for every tested engine. So we have two kinds of features in XSLT engine. We have the features which come from the standards and the proprietary one. So we have 4 standards which apply to XSLT. 2 true standards which are defined by W3C. One community-based effort, which is EXSLT, and a draft which never reach the standard status. XSLT 1.0 is the main deployed standard. For the record, it's really a moving target. This week I have some news about XSLT 3.0, which should be out in the following weeks, probably. So that's for XSLT 1.0. I have some tool which will generate this kind of output, which is the supported functionality of every engine. So that's a double. It's a XSLT engine from Qt and Firefox. The interesting part is that the specification defines 2 functions which are element available and function available. So I just define the norm in a XML format, and I pass it with XSLT, and I will automatically get this kind of output for any engine. So it's really easy. Proprietary extension. Here we have, if it's an open source project, we have the source code. We could have some documentation depending on the project. And if it's closed source, then you should use some disassembler or similar tricks. But as reverse is illegal in France, no, of course. So we need to identify the dangerous features. We have enumerate every feature available. I choose to restrict to fingerprinting because we need to know precisely which engine is executed in order to get the right exploit. File creation, because it's really interesting, and code execution, native code execution, for example, C# or Java execution. And we choose not to study read access because in a browser context it's somewhat difficult. There is a same origin policy. For example, you have external entities which allow read access, and it's a bag full of bugs thing. So if somebody wants to play with this kind of thing, I know that there is some player already. And I do not do some fizzing, even if I already crashed some application just by mistyping or selecting the wrong file. So I think there is a lot of bugs. So we need a POC. We have some very basic rules. Only one feature by file. No container, just a simple XML processing instruction. No obfuscation, no payload, and working in command line. We really need something easy to reproduce, so that's the proof of concept. Containers, that's the most difficult part of the research, because we need to find something which allow XSL transformation to be triggered. For the moment, I have 4 kinds of containers. I have HTML file, SVG, XML dsig, and sub-dsig. For SVG, there is a presentation about SVG tomorrow morning by Mario. There is a lot of interesting stuff. I will cover part of the XSLT part. And there is a lot of possible containers. So if you are doing chemical ML in your company, you probably have some gateway which understands this format. Perhaps we can trigger XSLT, I don't know. For single sign-on, I have some code which already work, so you can pawn a single sign-on gateway. Alright, it's always funny. So, and then we test some application because we need to find, we want to find some vulnerabilities. We have 3 big families. Office software, because it's deployed everywhere. Web context, so either client side or server side. And security solution, because I love to compromise on security solution. And then profit, everybody know, just pick your own. Get friends, get girl, get money, get fame. So, now we will detail the risk. So, as for features, we will divide in standards and proprietary extension. Okay, already seen. So, that's a small resume. For XSLT 1.0, we have a system property which allow to fingerprint the engine, and in XSLT 2.0, we have a result document which allow file creation. So it's interesting, but XSLT 2.0 is not very common. So as everybody supports XSLT 1.0. We know that we can fingerprint the engine. And here's some screenshot. So here's some HTML page, and here SVG file, which will fingerprint the underlying engine. So you have Microsoft, Firefox, Opera, and Chrome. libxSLT used in Chrome and Safari and iPhone, etc. We see here that this image is generated automatically. So you have a red dot if the engine is vulnerable, and a green dot if not. So it's really easy to check the result. Okay, so far we have nothing very important. So we need to look to proprietary extension. And here there is some interesting thing. Like for libxSLT, you can create file oops, there is some French. So you have several namespace and several method names with different parameters, and each one can create a file. So if you want to detect or block with IPS, for example, you will have some difficulties to detect every variant. That's for Xalan-J. You have exactly the same file creation, but you get two code execution. You can directly write to some SQL database, for example. I don't know who use this kind of functionality. Me for hacking only. And we can classify the engine in some families, 3 big families. Engine which are not dangerous because they do not include any proprietary extension. Engine which are safe by default. I mean, you have functionality for execute code, but by default it is not activated. So it's safe, but the counterpart is that it's very easy to backdoor. For example, if you have a SharePoint server, you can modify half a line in a VBS script somewhere, and you get code execution via SharePoint. I don't know how it could be detected by the defensive guys. So it's fun. And you have the dangerous engine, which are libxSLT, Xalan-J, Altova. There is probably more. It's the one I studied. And so you have code execution in Altova and Xalan-J, and you have file creation in libxSLT. So now we only need to find some application which use an XSLT engine, and if we find either libxSLT or Xalan-J, we will very probably win. Okay. So here's some application or language or framework. There is more vulnerabilities pending, but I'm waiting for patches. So Liferay is a CMS in Java. It's commercial or not, but mainly used as a commercial CMS. It's very expensive. And on their website, you have a list of customers with a search engine. So it's really cool. I know there is a Cisco developer network running on Liferay. There is the French Ministry of Defense running on Liferay. And given this kind of customers, of course, it's secure. No kidding. It's wrote on their website. You have blah, 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 most secure platform, blah, 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 OWASP. Ooh. Okay. So security. Okay. So really, it's a really nice solution, no problem. The fact is that it uses Xalan-J as a XSLT engine, so we should have a remote code execution, and we have one. So it's the patch is available since January, and I have a small video. So we have a browser window where we have a unprivileged user in Liferay. Every Liferay user has his own private page that he can edit. So we choose to edit our private page. And you have 2 shell windows. This one is waiting for the Apache logs on the attacker side. and this is a netcast listener waiting for a remote shell. So we choose XSL content as the portlet to add to our page. So by default, you have some information, price, don't know. And we just need to configure the portlet. We have a small form that asks for the XML and XSL location. So we just feed some value. In this case, the content is hosted on the attacker side. You can upload to the Liferay server and then trigger fetch local files. It works too. And as soon that I click on save here, we will see the XML and XSL file which are fetched by the application. And we get our reverse shell. So we are listing directories, blah, blah, blah. It works. Okay. So visually you don't see anything because XSLT transformation do not generate output, just a remote shell. Okay, something else. Altova. So Altova is a tool which is used to design XML file or web service contract, WSDL file, for example. It's very feature-rich, and here a small screenshot where I can execute a calc either from Java or from GScript, and the only difficulty is that the user need to press F10 in order to get the XSLT code executed. It's not really a problem because it's a standard way to use Altova. You open an XML file, press F10, and you get the output. So it's not very difficult. And it could be used in a targeted client-side attack. For Altova, there is some very fresh news. There is a new version which was released Monday, which now supports XML desig. So I didn't test this functionality, but we could probably now get code execution without the user pressing F10. So it's a small gain. I need to test. But if somebody already have this version installed, we could do the test quickly. Oops. So Altova is not very interesting. The fun part about Altova is that you can license their engine and use it in your application, but I didn't see any application using this engine. If you know about one, I'm more than interested by its name, if you can give it. Everybody know application using Altova? Dommage. So WebKit. WebKit is a framework used in numerous browser or browser-like application, like RSS reader, for example. It uses libXSLT, so everybody know that you can get file creation. The limitation, there is a few limitation. You can use arbitrary path and name, including // for example. But your content must be valid UTF-8. I have some friend working on this. It seems that we can bypass the UTF-8 filter, but I didn't see the code for the moment. So who is impacted by this bug? There is every Apple product, including Safari, iPhone, iPad, blah, blah, blah. There is the latest BlackBerry Torch, I think. I will probably be able to test this tonight. Thank you, BlackBerry. I don't know where he is. Okay, hi. And many Linux distribution, because WebKit is used in, for example, Epiphany, which is a browser from the GNOME project. It's used in LifeRA, which is a RSS reader, and you have a lot of application using that. Chrome is not vulnerable, even if it uses WebKit, because of the sandbox, which will restrict file access to the file system. So it's a good thing. Defense in depth is always a good thing. Patch is available since February. As far as I know, nobody applied it. So everybody can own every Safari browser, for example. This does not apply to smartphone, because even if somebody chooses to apply the patch, your smartphone will not update most of the smartphone, so it will be vulnerable until you throw it in the bin in 2 years. Okay, so that's LifeRA under Linux. It's the same. Oops, excuse me. It's the same SVG file, which detect libxslt and create a local file. And that's an iPhone, where you can see you have some very specific file. It's not very useful per se, because I don't know how to exploit this on iPhone, but I'm sure that somewhat of some nice idea on the subject. We can discuss about it later. And I have a small video. Okay. Alors, the scenario is somewhat complicated. We need somebody using Safari, okay, under Windows, and running as administrator. So you really want to be owned, no problem. So it's the latest version of Safari. Apple just asked me how I want to be credited, so I think they will publish something soon. I don't know. Here you have a window looking for the MOV directory under Win32, and here Process Explorer. So we will browse attacker-controlled web page. Excuse me, some problem with video. Okay, that's fine. Okay, so we just visited a web page, which tells us that he tried to create this file. So the payload is simply the Metasploit one, thanks to Yvan Le Fou. And then, okay, excuse me again. Okay, so we will see here the MOV file, which is created, and we will see the different worker process. We will pass the MOV file, and eventually we will get a nice calc here, which is running as a system, which is typical of MOV exploit. So just for curiosity, I have another browser, which is Maxton. It's a very little known in Europe. It's one of the most deployed browser in Asia, and it uses WebKit, so it's vulnerable too. It's the same demonstration, so I will cut it. Okay. More. PHP. PHP is always fun. PHP uses libxslt, so as everybody knows, we get file creation. So I reported the bug to the PHP security team, which has a very nice opinion of the subject. It's perfectly in the boundaries of what is supposed to do. So it's not a newly found security hole. including sarcasm. So I really do not like receiving this kind of email. So I release. And I create the patch, I verified it, and there is more than 2 months, I think, and it's still not applied to trunk. I don't know why, it's always the same thing. PHP is very slow to patch. But that's not the only bug in PHP. You have a very nice function, which is a register PHP function that is documented, and it allows to call a PHP function from XSLT XSL style sheet. So it's really great. And you have this kind of transformation. We just map namespace to PHP. It could be any value. And then we call our namespace with function and your PHP code directly. So here it's PHP info. It could be, of course, exec, system, whatever. So using Google, you can find Google code search. You can find some application using this function. I don't know if it's possible to control the XSL file. If it's possible to control it, you get remote code execution. So XMLSec. XMLSec, it's a library used to generate, verify, etc. XML-D6 signatures. So it uses libxSLT. And I really love security solution. Who is potentially impacted? I say potentially because not everybody uses libxSLT, and we could find some restrictive configuration where we can't get file creation. I didn't met any of this configuration in real life, but in my lab it's possible. So we have PKI and single sign-on solution, which are vulnerable. We have Swift IBAM. So IBAM is a protocol used by Swift to process, to manipulate information between Swift partners. And when looking for some XML-DSIG XSLT transformation, the only one I found was from the swift.com website. So here you have XML-DSIG file, including here some XSLT. So you only need to modify this file. Here you put your exploit code, and it should probably work on any Swift compliant XML-DSIG gateway. I really don't know why they choose to support XSLT in XML-DSIG. Okay. So I need to go a little faster. Okay, here I speak about XMLSec, which use libxSLT. If your own XML-DSIG application use Xalang, for example, it's a big Java application, really it's worse. You natively have a remote code execution when verifying signatures. And you can use this kind of file, that's sub-DSIG proof of concept, which will stop the underlying server. So it's not really dangerous, but it's really a good way to detect if the application is vulnerable. If the server stops, okay, it's okay, we win. So W3C edits XML-DSIG norm, and they have published last summer some document about how to use in a secure way XML-DSIG, and we will see that they have some very interesting advice. So advice 3, consider avoiding XSLT transform. And advice 4, if XSLT is required, please disallow user-defined extension. So one we can say is that absolutely nobody follows this kind of recommendation, which is a pity. And there I have some just some screenshot. I can't give the name of the underlying application, but it's somewhat interesting. It's a special XSL file which is designed to fingerprint XLNG configuration. So it's no, not only XLNG, any engine running under Java. So here XLNG, we have some information about the context. We have a Linux server, and we are running as a Tomcat 4, which is probably a good sign for us. We have some similar thing where we are root already under Linux. And here the XSLT engine is Saxon from Saxonica. There is a free and a commercial version, and it supports XSLT 2.0. And there's no yes, it's the same thing, but this time running as administrator under Windows 2K8, and it's still Saxonica. So I just show free solution when you get remote code execution as Tomcat or root or administrator, but it's the same thing. So it's really widespread, a widespread problem. Okay, so now we have some vulnerabilities. We need to exploit them in an efficient way. We have two primitives. We have code execution and file creation. For code execution, it's really easy. You just need to write a reverse shell in Java or JavaScript or whatever. In a functional way, that's the main difficulty. You need to use a recursion and not loop, for example, but it's not so difficult. And file creation, everything depends on the context. If you are in a web context, server side, you could simply drop a web shell the usual way, PHP, JSP, for example, JSP. File creation, if the running user is privileged and under Windows, you just need to use the MOF hack I demo with Safari. It works really fine. It's included in Metasploit. And if it's a normal Unix user, you should have a look to a presentation by the X-Force at ShmooCon, for example, and Akito Argosum in May, where they are dealing with USB attacks against Linux, and they had a lot of tricks for gain code execution or something interesting from file creation. You have some autoexec.bat, something similar in Linux. I don't know if you are aware. So it's a good target. Just write the file and get code execution at next robot. Okay. In order to conclude, so first for vendors, please read the documentation that W3C is writing for you. It's useful. Be polite with the researcher. We do not sell the information. We give it to you most of the time. So it's really cheap for you. So at least be polite. And use defensive def. As we see previously, Chrome is not vulnerable, and it's because of its sandbox. So it's really a good idea. For customers, you should not trust vendors. Everybody sell a very secure, compliant, etc. Application, but they never resist security audit. And you need to audit every critical application. You already know that, but it includes auditing every library used by the application. So it's a very big surface, but you really need to do that if you want to trust your application. One political point, I really think that customers should use monetary incentive to convince vendors to take security seriously. Microsoft make a big shift some years ago, and it's really proving that it could work. So I encourage everybody to use his money to have better application. For hackers and similar security researcher, common, there is a lot of bug. I only test perhaps half of the XSLT engine I know about. So there is a lot of stuff to do. Even just fuzzing, for example, you can have some bugs. And some more generic remarks. State-of-art XML DSIG or sub-DSIG application should not be vulnerable. So there is two solutions. Either you are vulnerable and your application is shit, given the standards, or you are not vulnerable, and okay, that's really a good point for you. I'm still looking for, no, I found one XML DSIG application which wasn't vulnerable to this bug, so it exists. We can deploy any XSLT engine in a secure way. You can configure you have configuration file, you have a compilation option, you have some parameters where when instantiating the engine, so just read the doc or ask somebody who already do that. And just for memories, first advisories about XSLT were published in 2001. And it was Guninsky versus Oracle and EA. So we are 10 years later, and a lot of applications are still vulnerable. So it could be a good idea to work on this subject. I have some few things again. So it's me with Mickey, yeah. And some question I always have. So this presentation was created with Prezi. Everybody asks that. Did I test your product? No, but I can do it. We just need to meet after. If you have some other question, there is some contact information here. That's over. Any question?
Thank you. You spoke about PHP and XSLT, and you showed an example about PHP info. Okay. And did you try to bypass security configuration inside PHP.ini, for example, OpenBSD, or something else? You know, you can restrict OS command, or did you try? And did you success in this?
At my big surprise, it respects the OpenBSD restriction, so you can go out. But it's only a positive point with this research given PHP. But you can't go out of BSD using this trick. Another question? Okay, so thank you.